Okay, so for this diagram, what I have discussed in the past is how it is the result of a circumstance where the relationship between the opposite and hypotenuse and angle, say for example theta, is represented by a sine function which can be graphed out in a circular structure, wherein at the beginning this line here represents 0 degrees. As it moves round all the way round here, at some point it will get to 30 degrees, which is one of the ones that's worth remembering. It will carry on in such a manner all the way up to 45 degrees, again one in my opinion worth recalling. So here we have a 45 degrees, and as we keep moving increasing the angle, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60. As we get to 60 degrees, you'd have something that looks like this, and you could follow that pattern consistently to note that it will produce a smooth circular function or circular structure when the angle increases, and that can be seen here. It's the same circumstance, like for example, let's say that there is, well, it'll be exactly half because we are aware of that for 30 degrees. That there would be an angle of 30 degrees if I were to draw, say, the opposite part of this diagram. So here is the opposite part of the diagram. So there is opposite divided by hypotenuse, wherein the opposite side is 1. So I can put that in here. So say this here is 1, and this side here is 2. As the function represents opposite divided by hypotenuse, it would be 1 divided by 2, which means it links perfectly to the length of 1/2 here. And we can do this at any other angle that we wish. So for example, the 60 degrees, which we've already discussed, would look something like that, wherein 60 degrees we've stated in the past for sine theta is √3/2. And so this is a length of about 1.7 √3/2, which we've discussed. I believe if we might even have one here. No, we did 1.4. I don't believe we did sine for √3/2 in a diagram, but I can suggest to you that it's around 1.7 for √3, which is just a little bit over √2 at 1.4. And so it comes up that this length, I'll just get through this part relatively quickly. This length is also 2, which is what's producing that circular-like structure, because it's very similar to a radius. These functions don't have to be circular in nature, because this length of your x-axis, well, they're circular in nature, but they don't have to be perfect circles, so we need to be careful with our language, because this length that I've just drawn across here can be changed in terms of how stretched out or squeezed in it could be, as it is simply just an axis to represent the angle. But this time, here, the height of this function we know will be around √3, so I'm going to put about 1.73 in there instead. But it's going to get a bit messy, but I judge you're aware of what I'm talking about. So that is why it's producing this pattern, wherein as the angle increases, so 30, 45, 60, 90, as the angle increases, you can visualize it coming from that center point here. You could do that. But another way of visualizing it, so you could assume that it's coming out from this center point here to produce the function, so that, for example, at 100 degrees, that would be 90, so 100 degrees would be from here, and it would produce the same value coming from here as, say, 80 degrees, because they're reflections of each other around that point. And the reason as to why that's something that we can do is simply because, as described a moment earlier, you can see sine functions as increases in an angle. However, one other way to do it with regards to these, or perhaps the more legitimate way of doing it, is to consider, well, say 45 degrees is around halfway there, so therefore the value of sine theta at 45, √2 divided by 2, will be there. And so 90 degrees is here, so the value of sine 90, which we know is, for example, 2 divided by 2 if your hypotenuse is 2, 1 divided by 1 if your hypotenuse is 1, so it'll be 1 is there. And so that's another way of looking at this function. Anyway, regardless, what do we know? We know that we want an angle of an angle of 53 degrees, and we suggested it came from a height of 0.799. So all I've done is I've said, do not forget that the y-axis is still a representation of opposite divided by hypotenuse.